Hey teachers, this is the instructional guide for primary 5, term 2, week 9. Okay, this week we're going to do one ratio heuristics followed by volume. Okay, so 2 booklets. Now, for the first booklet, heuristic on ratio, this is the use before and after concept. For this kind of question, right, it is really about finding which quantity did not change. And to solve the question, right, after you found which quantity did not change, right, you can then so-called convert, right, or convert or come up with the equivalent ratio based on that quantity that did not change. So what are the common kind of quantities that do not change, right? Sometimes it could be the item itself. So I'm going to put A. Right, let's say this is the A being the number of rate beats. Sometimes the quantity of rate beats, right, A did not change, and then B changed. All right. So in this case, if you have a before, right, you have a before and you after, right. What you can do is, given the ratio before and after, right, if the, let's say, quantity of A before is 2, right, and then after is 3. Then you know that you got to come up with this is the equivalent ratio that you need to convert to, right? So 2 times 3 equals 6, 3 times 2 equals 6. So new ratio is 3 here, new ratio is 2 here, right? You get the idea. Okay, sometimes it could be B, right? But if in the case it's both plus 2 together, then we say that it could be that the total did not change, right? That's possible as well, right? Total did not change, in which case then we need to convert the equivalent ratio based on total. Another common one would be difference, right? Difference did not change. So you got to read the question to understand which one did not change and make the conversion based on that. So primarily, that is the idea. So let's look at the first example. This one here. Now, if you look at the question here, number of apples to the number of orange was 5 is 4. After she gave 63 apples to her neighbors, the ratio of number of apples to number of oranges become 2 is to 3. Okay, how many apples and oranges did she have altogether? So the question, the answer here, the trick here, right, is to find out which item did not change. In this case, the oranges did not change, isn't it? Right? The oranges did not change, right? It's the apples were reduced, right? So previously there were ratio of 5 to 4, and then 63 was given away, and the ratio become 2 to 3. So we need to convert the ratio, right, based on this two numbers here, 3 and 4. Common multiple of it will be 12 and 12. So then you convert, right? So you get a new the new before ratio, right? Equivalent ratio, and then the after equivalent ratio. And so the question here is, after she gave 63 apples, which means there's a reduction in the number of apples. So previously were 15 units, now it's 8 units. Okay, 15 minus 8 was 7 units. So that change is that 7 units of apples, which is equals to 63 apples. Okay, and then from there, they can solve the question. All right, note what the question is asking. If it's asking for in the end, that they need to look at after, right, the ratio after. Based on calculate based on ratio after. If they're looking at before in the beginning, then they got to look at the ratio under before, equivalent ratio. A common mistake is that they would still convert based on the previous ratio, right? No, okay, you look at the converted ratio. So after you've done the conversion, this is what matters, right? The newly converted ratio is what matters, equivalent ratio. Okay. For this question, right, take them through. So they will realize that what did not change. The change is the what did not change is the difference. Okay, the difference between Ray and Sam's money did not change, right? Why? Because they both bought a laptop for $1,250. So the difference will always be the same. Another common example of the ratio remaining the same, right? Not change. The difference being remaining the same would be age, right? So you probably see a lot of this kind of question before. Ali is 22 years older than John. Okay, 3 years later, what's their age? That kind of thing. But you know that the difference will never change, right? The difference between the two persons' age. Okay. Let's see. So take them to question 3 as well. Question 3 is a bit complex because it you need them to do two parts of the, there are two steps. One is to, first of all, establish the ratio in terms of the number of dollars, sorry, number of notes. Okay, and then whereas here, okay, let's see. Oh, I may get it wrong. Let me two times 5. Yeah. Then the other one is about but the question is about the value. Okay, so that is the kind of question is very different. So you got to be careful. There's a later on the last question, right? Might want to take them through that. So they need to first find out the number of notes. Then they need to then do the ratio based on the value of the notes. Okay, before and after. So yeah, take them through this. So there you go. Okay, can be a bit challenging for them. Okay, so then you demonstrate one. I think since you've already done one total questions. Yeah, sorry, they didn't do a total one before. Okay, but you can try to get them to do this question. Okay, so question them, right? What did not change? They realize that total did not change, so they need to present it this way. They need to write the before ratio and then after ratio, and then need to do a conversion based on that. Okay, this one's a bit different, right? This one is because what did not change is not the total, but rather the total among the total between just Ella and Gary, because Ella gave money to Gary, right? So their total did not change, right? So this is a bit complex. Might want to take them through this. Rest of the question, I think, yeah. Then you do one question on difference before you can get them to do it, because you taught them early on in terms of difference. Okay. And then yeah, and then to demonstrate question 6. Okay. Or if you think they are confident doing it, you can get them doing class as well. All right. Now let's move on to the next booklet. So for the next booklet, it is on volume. Quite straightforward, right? The concept of volume, right? So volume can be measured in terms of cubic unit. So introduce them this concept of cube. Start with area, right? Now, if you go area is 1 unit times 1 unit, right? So that would be 1 square unit. Okay. But if you go 3 dimensions volume, 1 unit times 1 unit times 1 unit will be 1 cubic unit, right? That's what this 3 stands for, right? Cubic unit. The cube, the 3 stands for 3 dimension. Okay. So teach them this, right? How they can actually count to find out volume. Okay. So then get them to do the questions here. Okay. One way of doing this question, right, is especially for something like that, right, for counting, get them to count in terms of levels, right? So the first level will be 3 times 3, that would be 9 units. Second level will be 3 times 3, that would be 9 units. Okay, and then the third level, right, would be 9 units minus 2 here, minus 2 here, 5 units, or they can just visually count 5, and then they add them all up. Okay, this will be helpful, especially for the little questions when they need to, when there are actually a lot of levels that they need to count. Okay, so get them to do the guided practice, and then let's see. I've marked some little questions, because some of them are quite easy, quite straightforward. So we can try doing this here. Alice wants to form solid Q by adding some unit cubics to solid P. Okay, want to form solid Q, so basically, what do they need to know? They find out how the number of cubic units required for solid Q first. So this is 9, and this is 8, right? This is 3, this is 7, that's 3, right? So add them all up, and then same here as well, right? Add them all up, right? Take the total here minus total here, which is 20 minus 8. Okay, they will be able to find the number of units needed to add on. So quite straightforward. One more question here. So Thomas used some unit cubes to form 325 identical solids as shown below. So you want to find out how many unit cubes required to form 325 of these figures. So again, find out 3 times 4 equals 12 units here. 12 units minus 1, 2, 3, 4, 5. So this would be 7 units. All right, and then this would be 3. Add them all up together, you get the total of 22. Right, multiply by 325. That's how they do this question. And that's it, right, for P5 this week. Thank you.